So 2018 and paper 1, question 3. You can see it there. I'm going to work on that now. So my function is h of x equals cos 2x. X is any real number. Alright. So that's my function. If you want to, you could do a quick little sketch of your function. Cos goes through 0, 1. So it's going to look like something like that, etc. And we want to know about pi over 3. So x is equal to pi over 3, which is equal to 60 degrees. I'm probably going to work in degrees just in case. Okay, so a tangent is drawn at about 60 degrees. Maybe, I don't know. Let's go for about there, I haven't a clue. Okay, so tangent is drawn there. And find the angle that this tangent makes with the positive side of the x-axis. So we're looking for this angle here. Hopefully that makes sense there. Because if I take away the function, I'll be left with this kind of a line. Okay. And I want to know the angle that's made with the positive side of the x-axis. If for some reason, you know, maybe I haven't a clue, but if I was to draw it the other way, and I'll only know when I have a fair idea of what the slope is, but if it went, let's say, this way, then it would be this angle that I'm trying to find. So it looks like I'm trying to find an angle between 0 and 180 anyway, no matter which of those two options we're looking at. Right, so what are we doing? So we have the formula for the function. If we're looking for the angle, the thing that I know to do with angles, so now that we're looking for me, that sounds like a link between trigonometry and functions. So what do I know in trigonometry? I know my maybe we can even be a little bit more specific. It's not just functions, it's the slope of that line. So it's the slope of something. So where's the link between trigonometry and slope of something? That's tan. Why is that a link between the two? Well, there's your trigonometry, and opposite over adjacent is exactly the same as rise over run. They're just different words, exactly the same, and that's your slope. So if that's equal to that, sorry, no, so that's equal to that, and that's equal to that, and that's equal to that, then that and that are equal. So the tan of the angle is the same as the slope. And that should tell me, so it's the steepness of the line that's causing the angle there. Right, so we want the angle then. We are looking at a way to find slope. If that's the formula for the function, if I differentiate, that'll give me the formula for the slope of the function. Right, so I'm looking for h dash of x. So my function is y equals cos 2x. Does it look exactly like something that's in the log tables? No. Is it the product rule? No. Is it the quotient? No. So it must be the chain rule. So cos of u, where u is 2x, differentiate the left, differentiate the right, multiply them together. Now you might need a little bit of practice as your differentiation, I don't know. multiply them together. That's h dash of x. Okay. I know that x is 60. So we're looking for minus 2 sine 2 times 60, so that's 120. And do it minus root 3. So the slope at x equals 60 degrees, I'm after finding out, is minus root 3. Right, so now I'm going to find out my angles. Remember, if you are finding the angle, you're going to get loads of answers. You have to decide which one, because there's an infinite number of solutions to this. The tan of what gives me minus root 3? There's an infinite number of solutions. Like if you saw the sine of what gives me a half, sine of 30 gives you a half, sine of 150 gives you a half, sine of 390 gives you a half, etc., etc. There's the sine of minus 330 gives you a half. So there's an infinite number of solutions. We're looking for the one that suits best in this situation. Now, if we go back here and we're after seeing the slope as minus a third, I can actually cross out this diagram. Because the slope is negative, it means it's going this direction. So this is the diagram that's most accurate. And if we look now, I think we're looking for an obtuse angle. So we can either just throw it in as a minus root 3, or you can drop the minus. Remember, we're looking for a reference angle here. So we are going for inverse tan of, I'll go for minus root 3, doesn't matter. And we get minus 60. Minus 60 is down here, it's the same as 300. But it's only one of my reference angles, remember? You're looking for 4 that are linked. So 60, 300, 120, and 240. Check your calculator. What does the tan of 60 give me? Root 3. No. Tan of 120 minus root 3. Tan of 240. Now I'm already gone past where I know I'm going. That's a root 3, and the tan of 300 is going to give me minus root 3. But this is the answer, because this is like, that's an answer and that's an answer. There's an infinite number of answers even linked to those, but if we look at the question and we draw out the diagram, this looks like 120 degrees. Now that's an awful lot of different areas that you're picking from. So first thing is, that's your function. I would have sketched my function. Then I would have just even removed the diagram of the function and just had a look at the line that was created, whether it was this way or this way, we don't know yet. They told me that I want to know the angle that's met. Well, even from my 2 diagrams, the thing that makes a difference is how steep the line is. So we're looking for a link between trigonometry and the slope. The only link for me between trigonometry and slope is the tan of the angle, and you can see it all here. You need to get the slope. That's the formula for your function. So you needed to be able to differentiate using the chain rule. Get your slope. Sub in your x equals 60 into your slope formula, because you wanted the slope at x is 60. And you got this. Then you had to use your trigonometry information to finish out the question. That how many solutions is there to this? There's an infinite number of solutions. So you go and you get your 4 basic, what are they called? To me, they're reflections of each other. They're the linked angles. 2 of which usually work, 2 of which don't. Those 2 don't in this situation here. But if we had to pick between these 2 in this situation, we already had kind of even looked at from the start that it was an obtuse angle that we were looking for.